Okay. First of all, I would like to thank Simona for arranging all of this because I know that it's not typical to have online presentation than even some conferences like this. Uh, but she did her best to make this happen, and I'm very thankful. I'm very, I'm also very proud to be with you guys today. And today I'm going to talk about the concept of plausible deniability and tell you that it's important to keep the fact that you're using a privacy protocol private. You might wonder, why am I putting this mask on me? It's kind of, personally, I think you might think that it's pretentious. You might think it's cringe, but I'm doing this to make a point. Like, you see, I could be with you guys at the same room, sitting beside you, but you wouldn't recognize me because I'm not a famous person. But as soon as I put this mask on me, I will get the attention of everyone. So, in order to get even more private, I've decided to remove this mask. So, hello everyone. Hello again. My name is Keyvan, and let's begin. I'm going to share my screen. All right. So, this is the Ethereum blockchain, and we can say that every single mainstream blockchain in the world is like this. There are a lot of people, a lot of wallets and addresses doing different kinds of stuff here, and it's just naturally hard to uh, find certain people here because it's pseudo anonymous. But let's say we have this guy named Waldo, the famous Waldo, and for some reason, maybe he's an activist. Uh, People are looking for him. They don't know what is uh, where is Waldo in this picture, but they are looking for him. And Waldo is the guy who like decided to use a privacy protocol in like Ethereum blockchain. For example, he could use a Tornado Cash or Railgun or whatever. As soon as Waldo uses these protocols, this is what the outsiders will see from the Ethereum blockchain. They will see that some people are wearing these masks. And I think you've got the point. Like, uh, when I see this, I will instantly realize that I don't need to brute force all of the people, all of the addresses here anymore. If I just check out who were these guys who put these masks, I can find them. Like, I will just see the previous frame and I will find Waldo. As you can see, Waldo is here and we guessed him. Okay, so now I think we all agree that the mere act of entering a privacy protocol must remain private. And the formal phrase for this concept is plausible deniability, the ability to deny that you have been using a privacy protocol. But I think we can describe it in other ways too, like privacy in wanting privacy, like meta privacy or privacy square. And it's not limited to crypto. Like, crypto is not the only place you want to have privacy. For the internet, for example, there is a project called Tor Network, which helps people to hide the websites that they are visiting. It's a very useful privacy protocol. But if you use the Tor network directly and someone from the outside, some bad guy is like watching the network, they can easily tell who is using this Tor network. And it's just like putting that mask on yourself. which not only gives you privacy but takes your privacy. So in order to fix that, they added this concept of plausible deniability to Tor networks. They introduced bridges. Bridges are Tor relayers that are not publicly listed. They are like you can get them privately and connect to the Tor network through them. And if you do that, your use of Tor network will get plausibly deniable. You can deny that you're using the Tor network. Or there are also disk encryption software that provide this plausible deniability. So, like you can have some files on your disk, but if for some reason like someone get access to your disk, they can't tell that you have installed these software. They encrypt your data in a way that a person from outside, a person that has access to all the bytes in your disk can't tell you have been using this plausibly deniable encryption software. So I was working on privacy and researching on privacy protocols for the past few years, and we had this idea of having plausibly deniable privacy on Ethereum too. We already have privacy projects. We already have Tornado Cash. We already have Railgun and other, but they don't give you plausible deniability. As soon as you interact with these smart contracts, everyone from the outside can see that you're using them. So we introduced this new EIP 7503, also known as zero knowledge wormholes. I don't want to explain all of the technical details, but the TLDR version is that we want to enable reminting of secretly burned ethers. So what do I mean by effectively send my Ethereum to an address that is pseudo-random and it's provable because I can prove that this address is the result of a hash function. And we can also use the power of ZK Snark's zero-knowledge proofs to hide the value of R. Like, imagine we have a Merkle tree that records all of the Ethereum transfers that are happening on the Ethereum blockchain. If we have the Merkle roots of that tree, we can make proofs on top of that. We can prove that there is some amount of Ethereum in an address, which is address is the hash of some random value. And the EIP itself proposes to the Ethereum blockchain to remint that Ethereum when someone provides such a proof. So why is it better than cryptocurrency mixers? Because it's plausibly deniable. And not only it is plausibly deniable, it gives you a bigger anonymity set. So all addresses which have zero outgoing transactions and have some Ethereum in them are included in your anonymity set from day one. And you can always deny that you have ever used this protocol. But there are a lot of good reasons why Ethereum can't have EIP 7503, at least today. And part of that is because zero knowledge proof technology is very fresh, and it's just not a good idea to embed every new cryptographic primitive that we invent every day into a blockchain as big as Ethereum. It's dangerous. If there is a bug in the system, it will enable everyone to mint infinite amount of Ethereum. That's not good. So we saw that Ethereum is not going to have this on native layer, but you know what? We can implement it ourselves. Ethereum has a smart contract, and there are some tooling in the Ethereum virtual machine that gives us ability to do to make something like that. It won't be as good as if it's implemented on the L1, but it will be cool. So I built this Worm project, and it mainly consists of two ERC20 tokens. The first token is burnt Ethereum. Burnt Ethereum is simply an ERC20 token, which allows you to like mint mint it in case you provide a zero knowledge proof that there exists Ethereum account in the state Merkle tray of Ethereum blockchain with some amount of Ethereum, which its address is like hash or something. We are using the Poseidon hash here. And if I want to show you the code, it's basically just an ERC20 token. But thanks God, the Ethereum virtual machine gives us access to block hashes. And in the block hashes, you have access to Ethereum's state tree. And the state tree is basically a Merkle tree that includes all of the accounts that exist in Ethereum blockchain, their addresses, their balances. And we can take that and give it to our zero knowledge proof circuit, and the zero knowledge proof circuit can effectively verify that. And so we built this BETH, the Burnt Ethereum token. And the problem was that, so it's a one-way conversion. You can convert your Ethereum to burnt Ethereum, but you can't get Ethereum back from burnt Ethereum unless there is some demand for it. So we thought of a second token. We called it Worm, inspired from the name of the protocol, Zero Knowledge Wormholes, which is very similar to Bitcoin. It has a fixed supply. It has a mining system like Bitcoin. But instead of burning your electricity in order to mine a coin, here you are burning your burnt Ethereum tokens in order to mine more. So our thinking was that if we like have a secondary asset which has a limited supply and like limited supply, we can somehow make demand for burnt Ethereum token. It did actually work, but not very good. So we built this system, and we published both the burnt Ethereum token and Worm token. You can see that the chart for burnt Ethereum token is something like this. Whenever you see one of these red candles here, it means someone is using this wormhole feature. Someone has burnt his Ethereum and is using this protocol to migrate his Ethereum to another address. But because the Worm project exists and there is a liquidity pool for both of them, there is some demand for burnt Ethereum, and the price of burnt Ethereum will slowly again recover to 1 Ethereum. The Worm token itself works like this. So in Bitcoin, you get Bitcoins in 10-minute blocks, like statistically speaking, like you will get as much Bitcoin as you put electricity in the pool. So if like someone is so if the total electricity consumption to means a Bitcoin is like some value, if you are the person who is putting half of that electricity into the pool, you will get half of the Bitcoins minted. And the Worm token works exactly like that. It will track the total amount of burnt Ethereums that people are putting per epochs and the total amount of burnt Ethereums that each user have put in an epoch. And it multiplies these values and together with it multiplies the amount a user consumed for an epoch divided by the total PETH that was put by all users, and it's multiplied by total worm that is emitted in a block. Just like how Bitcoin rewards get halved every 4 years, we have like this smooth decaying of worm tokens per epochs too. Like every 4 years, the total worm that is emitted per 10 minutes is also haven't. We built like a mining panel for that. We launched it. It's working. It's not the only way to achieve plausibly deniable privacy, but uh, the reason I'm putting this in this presentation is somehow to show you that uh, although it's not obvious how to achieve plausibly deniable privacy on cryptocurrencies, it's something that is worth putting efforts in. And here I would also like to mention that the burnt Ethereum token is not here to compete, but it's here to complete, because the burnt Ethereum token, if you like assume that the PETH token is like the Tor network, then sorry, if we assume that all of the privacy protocols like Tornado Cash or Railgun that exist in the Ethereum blockchain are like the Tor network, the BETH, the Banks Ethereum token, is the bridge. It's the thing that helps you to uh, migrate your Ethereum to your favorite privacy platform without anyone noticing. And I've also put this uh, image of how Tor network works here to show you how this is very similar to what we are trying to do here. And yeah, thanks for your attention. Privacy is a human right. Privacy is normal, and someday I wish privacy also becomes formal. Thank you.